Okay, in this video we're going to look at a couple of examples of finding the difference quotient. So let's just recall what the definition of the difference quotient is. Given a function f of x, the difference quotient is this object f of x plus h minus f of x over h, where in this first term we've plugged in x plus h everywhere we saw x in the formula for f. So the first function we want to look at is the cube root of x. And this one's a bit tricky, so we're going to need this difference of cubes formula. So it says that a cubed minus b cubed factors, like a minus b, and then a squared plus ab plus b squared. Okay, so we'll start writing down the definition of the difference quotient. So f of x plus h minus f of x over h. And now we're going to use our particular function. So this is going to be the cube root of x plus h minus the cube root of x all over h. Now as is, we can't do much with this. But if we notice that maybe we can use this formula up here. So if the role of A is being played by this first term, and the role of B is being played by the second term, then we can multiply by something that looks like this in order to give us a cubed minus b cubed, which in this case would be x plus h minus x, which would allow us to cancel the h in the denominator, which is our goal. So let's see how we can do that. So we're going to multiply this by the cube root of x plus h squared. So notice that would be like a squared plus the cube root of x plus h times the cube root of x. That would be like a times b plus the cube root of x squared. That would be like b squared. And we're going to do that in the numerator and in the denominator. So the cube root of x plus h all squared plus the cube root of x plus h times the cube root of x plus the cube root of x all squared. So notice we've done this for a reason, and that is because it simplifies this numerator. Notice it simplifies this numerator down to this cubed minus that cubed. In other words, x plus h, the cube root, all cubed minus the cube root of x all cubed. And then our denominator is this long thing that we had before. So h times the cube root of x plus h squared plus the cube root of x plus h times the cube root of x plus the cube root of x squared. Good. But notice this numerator can be simplified. So this is just x plus h minus x, which is just h. But then this h that we get in the numerator will cancel with this 1 in the denominator, and that will leave us with our final answer of 1 over this term. So we have the cube root of x plus h squared plus the cube root of x plus h times the cube root of x plus the cube root of x all squared. And that's the final answer. Okay, I'll clean up the board and we'll look at one more example. Okay, now we're going to look at this example. F of x is 1 over the square root of x plus 3. So again, we'll start by writing down the definition of the difference quotient and then plugging in for our particular function. So this is going to give us 1 over the square root of x plus h plus 3 minus 1 over the square root of x plus 3. And then all of this is over h. Now what I want to do is clear the denominators in the numerator, and so I can do that by multiplying this entire numerator by this product of those denominators. So in other words, we can multiply by the square root of x plus h plus 3 times the square root of x plus 3. Good. Now if I do that in the numerator, I also have to do that in the denominator. So we'll do x plus h plus 3 square root of x plus 3. Okay, great. But now let's see what happens. This term is going to distribute onto each of these, but as it distributes onto each of those, it's going to cancel in a different way. So when it multiplies onto this one, the x plus h plus 3 is going to cancel, and when it multiplies onto this one, the x plus 3 is going to cancel. So in the end, we're going to end up with the square root of x plus 3 minus the square root of x plus h plus 3 all over h times the square root of x plus h plus 3 square root of x plus 3. So we've got something like that. Now the next thing we want to do is rationalize the numerator to make it simplify more. So let's see, if we rationalize the numerator, that means we need to multiply by the sum of these two things. So that would be x plus h plus 3 plus the square root of x plus 3 over the same thing. So the square root of x plus h plus 3 plus the square root of x plus 3. Okay, good. Now what we have is an a minus b, a plus b situation. And we know when we multiply that kind of thing out, we get a squared minus b squared. So in this case, a squared is x plus 3. And then b squared is x plus h plus 3. So we have something like that. And now that's going to be over this big denominator, which is h, the square root of x plus h plus 3, the square root of x plus 3, and then the sum of those. So this is going to be the square root of x plus h plus 3 plus the square root of x plus 3. Okay, good. But now we can do some simplification. So we can cancel this x with this x. We can cancel this 3 with this 3. And that leaves us with a negative h on the top. And we can take that negative h and cancel with this h in the bottom, leaving us with negative 1 in the numerator when all is said and done. So now I'll clean up the board and write the final answer. Okay, so on the last board we did all our simplification, but there wasn't really room to write the final answer. So now I've written the final answer. So we get negative 1 in the numerator, then the square root of x plus h plus 3 times the square root of x plus 3 times the sum of x plus h plus 3 under a square root plus x plus 3 under a square root. And that's the final answer.